Hello, Blanca. You are first time here, and you are an architect working at Zirkular. And basically, I think I will let you present yourself better.
Hello, thank you very much for the invitation and for the presentation. Yeah, I'm happy to be here. I will do the presentation in English, but if you have any questions, I think most of you are German speaking, so if you have any questions, feel free. I think because it will be a very long presentation, maybe 1 hour to 1.5 hours. Also feel free to interrupt if you have any questions or you want to comment anything in between the presentation. And I will try to go through the methodology for reuse in general, so urban mining, but also how to implement it into the projects and going through the whole cycle, and also trying to give some examples of projects we have done and different collaborations. I will start explaining a little bit about us as Zirkular. So this is a bit who we are right now, working in Zirkular, and we are many architects, but also there's biophysicists in our team, there's structural engineers who are specialized in reuse, but also more construction managers that are more specialized in the construction, and then also more project managers in general. I'm an architect and I'm doing more project management and things like this. And this is a bit how Zirkular started. So Zirkular was founded in 2020, so only 4 years ago. But it started with all the experience from Baubureau in situ, which is an architectural office who's been working already for 20 years with reuse. You probably know already, but maybe as a small, it's actually 4 sisters that work together. So Baubureau in situ was the first firma that was founded by Barbara Buser, and then from Baubureau in situ, there were 3 other sisters who were founded. There's a Denkstadt who does more project and urban development, participatory processes. There's Unterdessen who does lots of organization and management of temporary uses, so Zwischennutzung. And then there's Baubureau in situ who does more architecture, planning and execution. And as Zirkular, we do more, we're specialist planning for circular building and reuse in construction. And the idea is always to support each other in the projects. This is a bit the projects that we have right now in progress at Zirkular. So projects, because it's a newly founded, 4 years ago, but there's many different types of projects that we're working with right now. So we're working from construction projects where we're implementing reuse, to searching for reuse components in projects, to also more research projects where we're trying to, for example, here this Merkblatt für Wiederverwendung, when we're trying to establish the legal framework for reuse. But also a design studio in Karlsruhe University we have done, at CAS and Circulares bauen. So many different projects ranging from construction all the way into research, teaching, and also competitions. For example, we have also done many competitions. And a bit the question where it all starts is this extending the life cycle of components of materials. So our first question is, what is the life cycle of components in the building sector? And can this be extended to some extent? No, like, is this something that is set, or can this be re-questioned as well? No, is there a planned obsolescence? Is the building sector? And the question that we also ask ourselves, and where Zirkular also comes from, is from how the building sector is now growing. So this is a comparison from Agency 8000, where they have compared different apartment floors from the last 70 years. And what we see is that although the number of rooms is still the same, so we're going from approximately 4 rooms apartment to a 4-room apartment, the area of this apartment is doubling in the last 70 years. So this is towards where the building sector is growing. And of course, as a consequence of this, the spatial needs per person is also growing. So the material consumption that we are also using per person is it's growing every year. And is not growing in the way of renovating the existing building stock and then extending this one, But I mean, only 1% of the building stock in Switzerland is being renovated every year. So this is a very, very small percentage. This is a small introduction to give a context on circular and on how it was created. And this is also an important information of why we work with reuse of components and why we try to reduce the construction waste. There's around 80 to 90 millions of waste created in Switzerland and in general from all the sectors. And out of these 17 million tons are coming only from the construction waste, excluding excavation. Excavation is 57 million tons. So it's a very, very large, it's more than 2/3. If you take into account excavation and construction, it's more than 2/3 of all the waste that is being produced in Switzerland. And this is equivalent to 500 kilograms per second. And then also to give an idea of how much CO2 is being emitted per second, this 330 kilograms of CO2 per second. And this is equivalent to, you probably like the new buildings, they emit approximately in the city of Zurich, 660 kilograms per square meter. And this is equivalent to one flight to London per passenger. And this is a bit why we think it's important to work in the topics that we're dealing with. And this is the norms following SIA on how the CO2 emissions of products in the construction sector are calculated. So whatever it's in brackets is not calculated, but it's always following a linear system, from the extraction of raw materials all the way until the new construction of a new building, and then all the way to the treatment of waste. And what we're trying to do at Circular, we're trying always to keep as much as possible, so to create as little waste as possible. Of course, the first priority is always to keep the building as it is, transforming it only where it's needed to be transformed, or also adapting it, or when it needs to be densifying by extending. And then only when this is not possible, we try to reuse all the components. So dismantling the building and bringing them to a new building or to the extension. And only when this is not possible, we go into the recycling. It's also important to make this difference between waste avoidance, which includes everything that is preservation of the building, of the existing building and of the components, and a difference between waste treatment, which would be recycling or waste treatment. And this is according to SIA 430, in avoidance and disposal of construction waste, they really make a difference between waste avoidance and waste treatment. So that recycling is also part of waste treatment, and reuse of components and of course preserving the building is what waste avoidance is meant by. And also, maybe you have seen already these diagrams, but I give a little bit of context. This is a bit to also understand the difference between reuse and recycle. As I was saying, it makes a difference between avoiding waste, but also one of the important things, this is an example showing the recycling of concrete. And this is in the weight of concrete, there's 75% of the weight, which is sand and gravel. And when we recycle concrete, there's 25 to 50% of concrete, recycled concrete that goes into this, almost 70% of the weight. So this is good because we're optimizing the resources. There's a lot of part of concrete that goes into the recycled concrete. The problem is in the CO2 emissions. And what's important is that the cement is actually 75% of the CO2 emissions of concrete. And because cement is always new anyways, it's new, or you can change the type of cement, but that's actually where we should focus on when we want to reduce the CO2 emissions. But that's a bit the difference. When we reuse concrete, we can really make a difference in the CO2 emissions by reducing them. When we recycle, it does not make such a big difference. And also what we're trying to do, before I start already and I jump into the methodology, This is how we usually understand the role of architects, that they do a design and then they build it and then it's done. And what we're trying to do is to turn it into a circular, more holistic approach, where we're not only coming to design and to build it, but we're also taking into account other parts of the process. So we're also taking into account the material procurement. So where is the material coming from? How is it being transported? What are the logistics involved that can also affect the CO2 emissions and the energy consumption? Then in the design also, how do we design, for example, for disassembly? How do we design with reuse components? How do we build so that it can also take as many CO2 emissions and as little energy as possible, but also that it can be disassembled in the future? How can the buildings then in the future be used, that they can be maintained and that their life cycle can be extended? But also how can they be disassembled, that they can be maintained in their different layers? And then also the end of use of a building, is it really the end of its life cycle? Can we not somehow reuse it? And when that's not possible, can we not turn this end of use into material procurement to close the circle? And I will now go through the different phases, a bit to go through the whole process and how we work in these different phases of the process. So the first one would be, and one of the most important for us, is the material procurement. So where are the materials coming from? And to show a bit why it's so important for us to work in this material procurement and why it's important, this is a comparison of the CO2 emissions between a new building with gas heating and a new building with heat pump. And as you can see, the CO2 emissions have already been reduced in total by 1/3. So that's very good. The problem in blue, it's the construction emissions, and in brown is the operational emissions. So blue embodied and brown operational. The problem is that when we go to heat pump, although we reduced most of the 2/3 of the emissions, what's now the biggest problem is the embodied carbon and not as much the operational carbon. So this has already been optimized. And that's why we're trying to focus a lot on this embodied carbon now. And sourcing the reuse. So what usually we go through priorities. So the idea is that in the projects, we always try to find the components. First, we try to find them in situ, so in the building itself. So for example, we're now doing some projects with different architects where it's a renovation of buildings. And what we try to do as much as possible is dismantle the components as much, for example, the facade. And then when the building is done, we mantle it again. So this is the idea, that we find the components already on site so that there's no transport in the whole process. Then the second would be the client's portfolio. So when we're working, for example, with the city of Zurich or with the city of Basel, we try to work with projects that are already belonging to them, because this, of course, makes the whole process easier in terms of legal framework, but also in terms of logistics, no? So to make the times work and so on. And when this is not possible, we go to the architect's projects. So can we find the components we're looking for in other projects from the architects? And this can also facilitate the logistics, of course. And when that's not possible, we go to our own network. And when that's not possible, we go to reuse dealers, so Bauteilbörses. And and all this is done also through building screening. So for example, we do lots of building screenings from different buildings, and then we can use this as a data bank also for sourcing the material, but also through platforms. So there's many online platforms with reuse components. And now we have developed a planning tool, where the idea is also to be able to use this for sourcing the materials. And this is one example of what we're doing right now to source the materials. So this is a building screening, which is already starting to be, it's starting to be mandatory in some countries to make it, that it's obligatory. So hopefully in the future, it will be obligatory that before you demolish any building, you have to do a building screening, where what we do, we assess every component from the screening. And it is, we describe, for example, what is the reuse potential? Does it have toxic components? dimensions, description. And with this, we can do an assessment of which components from the building don't need to be demolished and would rather be disassembled. Another important part in our methodology is the data bank. So right now we're working with very, very complex Excel sheets and all the components that we find. So we have many source objects where we find lots of components, and these all go into one Excel. And then we have another Excel where we have all the components that we're looking for. And in this data bank, there's a match that it's done. So it's quite complex at the moment. And this is the matching. So these are what we're looking for and what we have found, and where we try to do this matching between both of them. And this is the application, the planning tool, which has been developed for over 2 years now already, and which we're now testing in our projects. And the idea is that we don't have to work with super complicated Excels anymore and a Google Drive with millions of Excels, but that everything is with a very nice interface that also our clients can use. So that's a bit where we're going very soon. And of course, there's all these platforms like Salsa, Use Again. I mean, I don't need to go. There's many, many online platforms. Yeah, please. It's a good question. I mean, very often we have many different types of clients. So we have, we work a lot with the city of Zurich, with the city of Basel, but also with city of Zurich, I mean, with public projects, because very often they can be more pilot and then we can explore more the reuse idea, but we're also working with architects directly that are interested to implement reuse. For example, Genossenschafts, they want to do reuse, and the problem, I will go a bit later in it, but sometimes it's a bit more difficult with the credit, because the credit needs to be available a bit earlier in the process, and that's why it's a bit more difficult with more conventional, but we work a lot with architects. Also, for example, we do competitions a lot, so consultancy in competitions with architects, but also with many projects. So it's not with architects, and yeah. Does that answer the question? Yeah. Thanks. And another way of sourcing the material that we have is, of course, to look at the plan of new buildings that are being built in the city, because where there's a new building, there's also a demolition site. And yeah, which is, of course, not the best, but when it's already going to take place, then yeah. And here I will show a small example. This is the SBB workshop where we work right across the street from this building. And this was done with Baubureau in situ. So we helped them with the CO2 calculations and all this, and the idea was to find the material. It's an old halle, and the idea was they wanted to take away the slab of the first level. Sorry, they wanted to remove the slab of the second level, and then here you can see it better here, to make a new level in the first floor. And for these, they needed a new structure, and they also needed to cut one of the concrete slabs that was existing. So the idea was, instead of demolishing this slab, because anyways it was in an existing building, it had to be dismantled. So what the idea was to cut the slab in concrete pieces and use it as foundations for the new slab that was being built. And this was done, the idea was then that these brown pieces, they are part of the existing slab that was already on site. And what's very good about this was that there was no transport which was needed to transport the pieces, because they were already there. It was only cutting them, which also made the whole demolition or dismantling much cleaner. And this is what it looks like, So actually what you see around the concrete, the reused concrete pieces, is new concrete. This was done quite fast. And what's interesting, I think, about this project, it's also that sometimes, because there's not a lot of time, we need to implement all these projects with reuse, because we need to reduce the CO2 emissions, and sometimes we're doing a bit applied research, no? So we're testing things out. And for example, in this case, there was not so much time. So there were some things that we think could be optimized. And what we find also interesting is to do a scenario afterwards on how could it have been optimized. So actually, when we compare a new concrete foundations when we compare them with reuse foundations that were done, there's only 11% of CO2 emissions reduction. And this was because there's a lot of new concrete which was poured in the connection. If we had had more time, or for next scenarios, what would have been done is to replace the lean mixed concrete with recycled concrete aggregate, but also to reduce the covering area of the blocks around them, and maybe to cut them in a different size. So these are, because it's a bit of applied research, we also always try to see how it could be done better the next time. And this is another example that we are just sort of finishing a component, a material procurement that we just are almost finished with, and it's the Kerenzetberg tunnel. So it's a tunnel that is 5 kilometers long, and it was already in use for 30 years. And because of the norm, they needed to do an ancillary sort of exit from the tunnel. And the construction of this would take around 1 year. And in order to build it, they needed these concrete plates, which are 4.5 tons each, and there's 2,000 of them. And they needed these concrete plates for only 1 year, and then done. And also there were 20 kilometers of these wooden beams, which were also only placed for the construction, and then 1 year, nothing thought. And what's also, so we did some tests. They contacted us, we did some tests with a structural exploration lab from ETSAB. And what was interesting for their analysis is also that these concrete plates, they were not done with a normal armierung, no? And they were actually done with this plastic reinforcement, which makes it very easy to produce because you can actually insert them. It's a very innovative solution. The problem is that it's not yet known how to recycle them, because when you put the concrete under a very high temperature, the plastic melts. And it's not possible to separate them, to separate the concrete from the reinforcement. So then that was also why we were contacted, because then it's very expensive to get rid of these plates because you cannot recycle them. So you literally have to send them to the depot. And so we tried to, there were 2,000 of them. So we tried to place them in different projects because it's also a very valuable material. They were 22 centimeters thick, almost 3 by 3 meters big. So we tried to place them in different projects. And of course, in every project, they would ask us for different requirements. So we need a Druckfestigkeit test to see, this was one of them. We need a slippery test to see if you can use it as Bodenbelag. No, we need a Druckfestigkeit to see if they're strong enough to support, for example, vehicles. We need, etc. I won't go through all of them. But for example, one of the tests that was interesting, I won't get too much into detail to not make it too geeky, but one of the tests that was interesting was that the salt that would be put in the winter so that it doesn't become slippery, this salt would disintegrate the concrete because the concrete was not thought to be used as a floor finish outside. So in all the projects where we wanted to place them as floor finish, in the analysis, it was saying that we were not able to then put salt on them. And of course, all the clients said, we cannot control that. In 5 years, someone will come and will then put salt on it. And the problem is that then the concrete, a little bit, and then what happens then? No, I mean, it's very little. We don't really know exactly how much. It's very, very little. But then the problem was that the plastic hairs would come out. So then we spoke with the concrete firm, and they said that we could just burn them and that would not create any toxic, because of course we were also worried about the plastic toxic that could, but this is something that they said would not be a problem. And that was one of the, for example, interesting tests. Another of the tests that was interesting, for example, in the slippery test, they tested both sides of the concrete plates. And unlucky, very unfortunately for all of us, the upper side of the plates was not good enough for the slippery, but the one below was good enough. So that meant that if we wanted to really to follow this, we would need to turn all the plates around. And this is very complicated because the anchor points of the tunnel plates, they're only thought to be carried in one direction. So to turn them around, you need to create a very, very complex system. So this is still in process in some projects. I mean, it's still in process to see what will happen if it really, I mean, yeah, we also tested, for example, to sand them in different ways. So to make them have different finishings exactly for this slippery idea. How much would it be per square meter if we wanted to sand them with water, pressure, or with different treatments? But I mean, this was quite an interesting process. And this is the first concrete plates being installed. So this is the temporary cantonal school in Uster of the building department of the canton of Zurich, where 88 of the plates were installed directly without any storage in between. So they were brought from the tunnel directly into the school and installed. And here is the storage for the City of Zurich competition for the ETSAB Recycling Center, where we transported 288 concrete plates. And I mean, Verena can tell more about it because she's the project leader from the City of Zurich of the project. So. And I mean, they all arrived last week. So now they're all in the storage of the City of Zurich, 288. And yeah, I will tell a little bit more about the project after. Yeah. Sorry, I thought it was clear. Here, so they're the floor finish. So they were used as floor finish, but also as the slab of the balconies. And the idea, this I cannot yet say because it's still not implemented, but the idea here is to use them also as floor finish and as foundations maybe. And so then that was the material procurement, then I go to the design. So we don't design ourselves, but we do consultancy with architects. And how to design with reuse from the start. So there's basically two ways of designing with reuse. One way is when you already have a project. For example, architects that have a project and they want to implement reuse, and then they come to us and we see which components could be found and the design should have to be adapted to them. So that's one way. And the other way is when you have a catalog from the beginning with reuse components and you do the design from the beginning with these components. And of course, we're very interested in this approach of designing from the beginning with reuse, because then the design does not have to be adapted to the reuse. So I think this will also change very much the aesthetics of reuse. So one of the ideas that there is now is that reuse brings this a bit collage aesthetic, because you get the materials you get and then you need to adapt them to the design. But of course, it's different when you design a project from the beginning with a catalog of materials. And that's what we're also now testing with also applied research. And this is, there were two competitions that were done, one with the City of Zurich and one with the City of Basel, where we did a catalog of components with the city. And this was the base of the competition. So all the competitors, there was a website and all the competitors could choose which components from buildings in the city that were supposed to be demolished, which components they wanted, also with a CO2 that was associated to it. So they could see how much CO2 they were saving with each component. And then they would do their design directly from this catalog of components. This is the one in Basel, which Basel city organized. So this was done with most of the pieces there. The biggest mine there was this park house that is now in Basel. It's a park house from the 60s. There was a competition already in 2008 where the park house had to be demolished and there would be a new housing development coming there. And with all the movements in the last years, of course, nobody wants to demolish it anymore. And that's why it was used as the basis for the competition, so that it would be reused. And the competition, there were two competitions done out of this catalog, and one of them is the Valkebeek Nord CUD, which was a housing competition. And this is a bit what was done for the competition the winning proposal by Par-based architects. And what's interesting is that they re-questioned, so they used the prefabricated concrete slabs, they used them as facades. And what's also interesting, which is something that I will go a bit more through it, but they reuse the columns of the park house. You can see them here. So this is the same columns that are in the park house, but of course the height of housing is very different from the height of parking. No, so housing requires much lower height, and what they did, they used these connections in between these new connections in between the columns to adapt the columns to the new heights that the housing requires. So this is one of the principles that we use a lot in reuse. So we always use these new pieces to make the connection between the reuse. And then I will explain a little bit about the City of Zurich competition for the ETSAB Recycling Center, which was also parallelly doing this, creating this catalog. Here there were 5 or 6 different mines. And the idea was similar, to do a recycling center out of these components. And yeah, as you can see here, you could actually shop components. So you could say, for example, I want to use 110 linear meters of IPE 300. And then you would automatically see how much CO2 you were saving by doing this. There's not really an official way of calculating CO2 emissions from reuse components. We only have right now the experience from K118, which is the building that was done with reuse in Winterthur, which I think you will go visit, no? If you haven't yet, no. Tomorrow, exactly. And yeah, and that's a bit, that was a bit the comparisons also of the THEs, of how much it would be reduced, and all the competitors at the end had this sort of reduction of the CO2 emissions. And a bit to show also this, how the designs were varying. So one of the topics that sometimes there's a lot of skepticism is that if everyone has the same catalog, all the designs will look the same, no? Because everyone is using the same minds in order to design these projects. And this is a bit, I show different proposals, or a bit to show how different all the proposals were. This is the second prize for the competition from Studio Hammer. And this is the third prize by Studio Burkhardt and Lucas Michael Architects. And I mean, yeah, with the same, out of the same catalog, something completely different can be done. And this is also one of the proposals, so 10 Studio Mitassemble. And that's the winning proposal by Garcia Pulver Architects, but a bit to show what a variance of schemes one can design. So it's not that the world is over for us architects. There's still a lot of spectrum in the design, no, to be done with reuse. And you can see also, for example, that they also use this idea of the new puffer elements to make the connection between reuse. So for example, because the steel columns are all a bit different height, the new concrete pieces are assuming this puffer function, no? The same way that Parabase was doing it in the columns, here's also something, no, in this same, it's something we do a lot in reuse. And this is also a diagram from Garcia Pulver Architects from their proposal, where these are some of the mines that they were reusing. So they used some mines from the catalog, but they also brought one mine, for example, from their own knowledge that they knew would work in terms of time, the Schneiderhalle, and what they want to do with all of them. And what's interesting, for example, the recycling halle, they wanted to build it 1-to-1. So dismantle it as it is and then install it again, exactly how it is. But the Schneiderhalle, they would change a lot of it. And I won't go so much into it. But basically what's very important is that to have a very strong impact in the CO2 emissions, it's very important to, the most impact you can make is with the structural components. And here, most of the reuse components were structural, no? So there's a lot of steel being reused. There's also concrete being reused, so in situ concrete being had and reused, and then also wooden structural components. So that's also where most of the impact comes. And here in the implementation, you will see then tomorrow the K118, but these are some of the strategies that were used in the K118 by Baubureau in situ. Some of the strategies, no, that we also use very much when we design with reuse and for reuse. So for example, one of the ideas is to never cut the components specific to the needs. So you always leave them the size that they are and then they overlap. because the idea is to not create dimensions that are just touching each other so that you can also reuse them in the future. That's why, for example, in K118, I mean, I think Mark will explain it a bit better tomorrow, but the idea is that the facades here, they're overlapping each other so that they don't need to be cut to a specific dimension. Also, of course, that the selection of materials, so that we always work with robust raw materials. For example, here there's not a photo, but the parquet was reused, and the idea is that parquet, you can just sand it. I will now go through it a bit in detail with the costs. I will show a bit of an analysis of what we have, the experience that we have had until now. But yeah, the idea is also to, I mean, I will now get to the cost and but the idea is also to make all the systems separated, that they can be separated from each other. So for example, that the facade, if the facade needs to be repaired, that you don't need to dismantle the whole structure, obviously, that you can just dismantle the facade, or if the staircase needs to be repaired, or if something is not working, that only all the layers are separated from each other. And flexibility, this is also this principle of the connector, so that what's very difficult is to always design with reuse component with another reuse component, because there's a lot of uncertainty with reuse. So for example, it's very difficult to say, I want a window that will be exactly 2.05 meters by 2.35. So usually what we try is also always to look for windows that are 2.1 into 2.3. And then what helps a lot is that then there's a new component that it's next to it that can absorb this difference. So for example, if the window that we find is 2.1, then the new component that it's next to it can just be a little bit bigger. And this is what we try to recommend. I mean, in some projects, we also do reuse with reuse, but of course, it's always a little bit more complicated. And yeah, and again, I think I went through all of them. I mean, the stairs, the stairs were also reused. So in this building, yeah, the stairs were reused, and then they didn't have the same height as the steel structure, which was coming from another building. And then again, there was this concrete podium done just to make it adapt to it. But also the steel structure was, so there's, for example, some connection details that are making these new puffer elements between pieces. And I go to the construction. So how is the process different? Reuse compared to a conventional project. These are the stakeholders, so the stakeholders are very different. We always like to say that there's new professions that are being created, but it's true. I mean, in Circular, in our team, we have a team of component hunters, so Bauteljägerin, that actually go through all the demolition sites, trying to see what has potential, doing these building screenings and trying to find treasures in these buildings that we can implement into projects. But there's also, for example, site manager for circular construction, which is very different. There's also civil engineer for disassembly, but also the expert for disassembly. It has to be someone specialized that knows how to. It's not the same thing to demolish a concrete building than to deconstruct it. So cutting the concrete and so on, or also to I mean, I will show now some examples, but to disassemble, for example, a steel structure. It's also something that is quite specific, and that now different companies are getting specialized. So yeah, the demolition contractor, and so on, and yeah, and these are also the different milestones. So this is the construction process compared to the normal SIA phases. What's a bit special when we work with reuse is, as I was saying before, that the credit needs to be available a bit earlier in the process. So either if we want to start working with a catalog, all the tests of these components need to be very early in the process. And this is a budget or a credit that needs to be invested into the project before the project is even there. So that is already something. But even when we try to implement reuse in projects that are already designed, it's also the credit has to come earlier. So we need to start looking for components as soon as possible, because, for example, in K118, the steel structure that was found did not have the right dimensions, and the whole sections, the whole drawings had to be adapted to this to the structure that was found. Also, the idea is then that we start looking for the components as soon as possible. But of course, usually in the CA phases, the credit for a project, it only comes once the BAU project is submitted. But ideally, once the BAU project is submitted, if we then find a steel structure that has complete different dimensions from what we're looking for, this is very difficult then after the BAU project. So we try always to have this credit very earlier on in the project. And also what is important is that we want to be finished with the search of components before the tendering goes out to public. Because what's also important is to make sure that if we don't find all the components we're looking for, that we can still acquire new ones. So the idea, for example, if we're looking for 200 lavabos and we only find 70% of the lavabos, the idea is that we can still, in the tendering, place these 30% of lavabos that we have not found. And this is, we always try, I mean, with reuse, there are some uncertainties and some risks, but we always try to minimize this. And this is one of the ways we have to minimize this. I mean, this is a bit the process, no? How we find what I already told, no? How we find the mines, how we try to match them with what we're looking for. So what you were asking before, no? About who are our clients, no? So usually here we have the Bauträgerschaft and the architects that they define the requirements of what we need to look for. And this creates these search profiles, which we then match with the mines that we have available. I will now go a bit more in detail through it. And then what's also very different, how you were asking about the financial investment, it's the costs, so the difference in costs. So what we always, because it's also a bit uncertain, depending on the mine that we will find, the costs can differ very much. It depends on the costs of dismantlement, of the costs of transport. Most of the time the material is free, but this is not always the case. But most of the time the material is free. But of course it depends on what kind of mine. Also the storage cost can be a big challenge in terms of costs if it's not a public project or if we need to pay for the storage. And this is something that is difficult to assure in the first place. But what we always say, we take the costs of new components as a limit. So we'll never, it's very difficult to say, but we try to not overpass the limits of the costs of a new component, at least overall in the project, so that even some components will be cheaper and other components maybe will be a bit more expensive, but that overall it's not more expensive than new components. And this is good because it makes it easier that the CAFA, the cost, it can stay as it is, as it would be with new. And what we do is we always then, every time we find a component, we always compare the price of the component as new with how much it would be this component if we want to reuse it. And we always show this comparison before we decide to take, or the client decides to take a material. And so then the Gebäude cost and the building costs are always 1-to-1, but the planning costs are, we say usually 8 to 20% between our honorars and also the architects and the other Fachplanners and the other consultants. And this is a bit to show this difference of cost that I was explaining more in detail. So this is an example. For example, I think this is done for a steel beam. And as you can see, if you would just reuse it as it is, then it could even be cheaper. So yeah, maybe here, for example, we had to pay for the material, then for the honorars, and this is for the transport and logistic. So here, for example, it was 7 francs per square meter cheaper. But of course, if you have to do a new finishing, or if there's corrosion shoots and all these, or for example, if there's PCB, then, and you need to do a new finishing, then this becomes a lot more expensive, no? And this is what we usually, I also won't go too much into detail to not make it too heavy, but this is a bit an overview of our process. Usually we divide our work in 2 phases. Phase when we get these projects that are already in a FOD project, for example, phase. We do a phase 0 where we do a potential analysis. So we do Gebäude screening. If there's an existing building, we do a building screening. And when there's not, we don't do it, but we do a potential analysis. So we see which components have potential to be reused in the project. and we go through a list of all the components where we see potential. And usually we try to do a top 10 or top 5 where we want to focus ourselves. And these usually we can choose doing a CO2 analysis or how much waste can we avoid by reusing these ones. And this would be the phase 0, so until the first line. And by the end of this, we do top 5 or top 10. We do the 10 components that we think could be reused in the project. And we do a search profile where it's stated, for example, we want to find 35 windows that are between 2.3 and 3.2 meters each and that have an UVert of an U value of something. And with these search profiles, then we start looking in our minds. And when we find a mine where there's a good match, we do an Erwerbsantrag where we do this comparison of costs. So we compare what would be the new price versus what would be the estimated price of the reuse component. And if this is approved by the client and the other consultants, then we do all the coordination of dismantling, transport, and so on. There's not a rule. I mean, very often, I mean, there's not a rule. Usually, it really depends on the component. So, for example, in the concrete plates, it was the tunnel, the persons in charge of the tunnel who took them out of the tunnel and brought them out. And they would also take them with the crane that they had on site and put them on the truck, into the truck. And then from the truck on, it was already the new owner of the component who was paying for that. The thing is, most of the times the owner of the component, so the first owner of the component, he anyways needs to dismantle or demolish the building. So sometimes we also try to negotiate this because sometimes the new owner of the one that is buying the component is asked to pay for the dismantling effort. But of course, they would then, the previous owner would then not need to pay for it. So this, it depends on how much they want it, no? I mean, that's why it's so important to make this assembly, to make it mandatory so that it's not I mean, I will go through it at the end, but it's a question. I mean, for me, what makes sense when you're negotiating it is to deduct the prices of the demolition. So, for example, if the new owner will pay for the dismantling of the object, at least that he reduces the costs of demolition that don't need to go through the previous owner anymore. Does that make sense? And for me, that's what makes sense. But for example, in the example of the concrete plates, the previous owner of them, he would have had to pay 150 francs per plate if he wanted to get rid of them. So then the idea, what we try to negotiate is that actually he would have to pay us. He would actually have to pay us for the material, for us to take the material. No, but this didn't work out in this case. But it didn't work out in this case. But just to understand a bit the idea, that's how we think it should work. That's how we try to make it work. But of course, it doesn't always work like that because sometimes people are not motivated to do it. And of course, the work that the people in charge of the tunnel had also to take them out to do all the. I mean, yeah, it's not yet the case everywhere, but ideally it's how it should be, in my opinion. There's many ways that we're now implementing. For example, in some projects now, what we do in the tendering for demolition, there's also a section where it's included that they invite all the Bauteilbörse to come and to check if they want to take anything from the building. So that's, for example, one way. Another way, of course, is to do a building screening. So this is what a building screening, this is what I have shown before, where we do this analysis, or some other Fachplanning, another office also, where all these components are cataloged and they're potentially stated, and then it's easier also, no, to see what could be reused in other projects. The first option that I have said, not really, because to invite the Bauteilbörse to come to see if there's some components that they would be interested in, this is not really, there's not really investment there, no? I mean, there's one visit that the demolition contractor needs to do with the Bauteilbörse, but this is not a lot. But yeah, I mean, the other option is to go through all the components, put them online. No, that's also something, the Vermittlung, that's also something we do sometimes for some projects. Of course, we cannot assure that all the components will be reused. No, I mean, it's difficult because, for example, we don't buy the components. We only sort of do the coordination. So for us to reuse a component, we really need to find another project that at the same time needs this component. Because the idea is not to be paying storage costs for material that is not being reused. So we only buy it when we really see that there's a lot of potential in the material. We work a lot with public projects, or also, for example, with insurances that have implemented this circularity into their, into their, and that now need to do these building screenings that need to make these components available, that need to try to reuse. And this is something that is happening a lot now, I would say. I'm not sure if that's, I mean, I guess as a private architect, it's a bit more difficult, no? Like, I mean, I had some friends, for example, that redid an office, no? And they did a whole building screening, and they spent, I don't know how long doing this building screening. And then they sent me and they said, you can come pick it up next week. And, and I was like, it doesn't work like that, like we cannot, I don't know how many square meters of the suspended ceiling. And, and at the end, we tried to make a match, but there were no matches right at that moment. And I was like, we cannot, if it's in 1 week, we cannot take anything. And they were very disappointed. They were like, oh, reuse, it's all fake, nothing works. Like, we did so much work for nothing. It's all not true, completely disappointed with life and with sustainability, and like, I mean, that's why I also like to tell the truth that it's not so easy, because if we had all the storage space in the world, and we could then store, that's ideal, the future, that we could store all the material, and then, but right now we need to find a time matching so that you have a project that needs this component that is going to be demolished, so that we know exactly for how long it will have to be stored, how much we will have to pay for that. It's not so. I mean, we're trying to make it more agile, but yeah. So maybe I'm in a bubble. Sometimes I need to leave the bubble, but I have the feeling there's a lot being done right now in terms of building screening instead of. I mean, for me now, my opinion is that it's not so typical demolition without any test at all to be to try to reuse something from. I mean, but it's also my bubble maybe. So. But I think the cities, for example, in Basel and in Zurich, they're really making an incredible effort to advance this. So this is happening. This is happening already. Yeah. I mean, this is the system cradle to cradle. So in cradle to cradle, the circular sort of product, it's like a washing machine. You don't buy a washing machine, you lease it, no? So you lease it for 100 washes. And then you give it back to the producer, and then what's the consequence of that? That the producer makes a product that will last longer, because it's his own product. You're only leasing it. So then he will design products that will last longer in time on one hand. And then on the other hand, he's the one that knows how to repair the machine. He's the one that knows how to make a new machine out of the pieces. So the idea when we talk about a cradle to cradle product is that you lease it for some years and then you give it back. And this is already being done in the construction industry as well. So, for example, you can lease lifts. You can lease, for example, carpets in double floor. This is something, I mean, Deso has a product which is also cradle to cradle. It's monomaterial. So you lease it for, because offices, you change a lot, no? Maybe you're there for 20 years, then you want to leave, and then you give back the carpet. And then because it's monomaterial, they can remake a new carpet very easily.
Kitchen
for kitchen, for lights also. And the idea is, I mean, this I don't know, but maybe in the future this will also be done with structures. Why not? There's a lot of big companies also of concrete and steel that we're working with that are now implementing this in their system. So, for example, for some projects, we're now buying directly from, for example, Eberhard, concrete from Eberhard, because as you say, they're the ones that know the best, what are the qualities from the material, how should it be maintained, the reinforcement plans, they're the ones that know. So what you're saying, it's exactly how I think in the future it should be. So that in the future, all the components, they go towards the producer back so that he can repair them. Yeah. I think that's where it's going, where it's leading. I mean, that's also my personal opinion, but I mean, yeah, but there's already lifts, carpets, like you were saying, lights. Philips has like, I mean, there's a lot of now product development in this direction. It depends a lot because there's some components which need many tests. Like, for example, these concrete plates that I showed, we did, I don't know, 8 different tests, then 9 tests, which took some time. So the slippery test, you have to take the different tests to the laboratory. You know, some of these tests, they take very long. For a steel structure, if it's, for example, from before 1970s, we also need to do many tests to it to see the steel quality, if there's pollutants and different things like that. So there's some components that need a lot of tests prior to us saying we take them. And then there's other things which don't. For example, a lavabo, you can see the lavabo, you can try to wash it a little bit to see if it's, you know, if it's easy to clean. And then you can very easily see if it can be reused or not. So it's difficult. There's very complex components and very much easier components to dismantle, and it depends then on that. I mean, the earlier we have the information, the more time there is to find a match. I mean, it's a very big chance. If, for example, you say you have a fitness center, and I'm like, oh, I also have a project with a fitness center, you know. And then, but of course, if you say it in 2 years, no, I'm joking. Yeah. I'm joking, but I mean that if we have 2 years, then the chance increases, no? So it's always, sometimes it works super easily. Sometimes all of a sudden we get I don't know, for example, blackboards from school, we get lots of them, you know, and these are, sometimes it works, you know, that you say like, oh, we could use them as an interior wall in a lobby, you know, and then, yeah, but it's hard to say like that as a standard, you know. The more time there is, the easier it is to plan on. I mean, there's lots of platforms online. So the ones that I showed, some platforms, like reuse again, there's different platforms. The idea from Zirkular now is to make an alarm system, that there will be an alarm so that you can sign up, for example, I want windows. And then every time that a window comes up in one of these platforms, you will get a message in your email, for example. You can ask the Bauteil board, and you could then call them and say, hey, I'm demolishing this big building where there's this and this. Are you interested to come by and check it out? And then they could go make a visit, and then they can assess whether there's components that they would want to take. So this is a bit the steps that we go through in one of these projects where we, you know, the architects, they have already the full project and they want to do reuse in their project. And we then we do a first potential analysis in this phase 0, which I was mentioning previously. And we go through the whole list of components after EBKB, and we go through all of them to see what has potential to be reused. Sometimes, for example, for some projects where we have also done like a CO2 comparison, which components could have the biggest impact in the project in terms of CO2 reduction, or in terms of material reduction, and also based specifically in the project, no? So, I mean, there's many things that can change depending on the projects, many factors, and this is one example, no, on how we chose these top 5 or top 10. Yeah, this depends a lot on the client. And then once we have these elements that we want to reuse, that we want to search, that we want to look for, we create these search profiles. The idea is that these search profiles are as open as possible. So the more flexibility we have, the easier it is to find the component. This is an example, for example, what I already mentioned before, the windows. No? If we say we want 2.03 meter windows by 2.1, it will be almost impossible to find. So the idea is always to make an in-between, no? And also to specify other, for example, which U value does it need to be? Does it need to be triple glass or single glass? Dimensions, so that all the requirements are stated, and also until which date do they need to be, can we look for them, until which date do they need to be delivered in the construction site. And with these search profiles, we can then start searching for component. Once we find matches, the idea is then to test them in the design. So sometimes, for example, this is a Hobelberg met als Wohnen from Pascal. We were from Pascal Flammer, which we were Fachplanungs there. We did the consulting there. And for the handrails, the material that would be used for the handrails was open. It could be a rail, it could be a gitterros, and different options were tested. And at the end, what we found was this gitterros, and that's how it was implemented into the project. But the idea is to keep this openness a bit, or this flexibility in the project, that different materials could work, or different dimensions, as much as possible, because this makes the search much easier. And this is also something important to find the right match in terms of timing, that there's not 10 years of storage in between, especially if we need to pay for the storage, to try to do this of course, this also speaks against the idea that the project doesn't need to be adapted. So, for example, when the concrete plates were found right on time for the school, that meant that the whole design had to be adapted to them. So that means tons of redrawing. So it's also not the best to find them right at the same time. But of course, it's good to find them right at the same time if it doesn't need to change the design. And at the end, this is what I was saying before, that you can find in the book K118 at the end. So it's this comparison. There's a CO2 comparison and a cost comparison on the difference between the new component and the reuse component. And you can see how much CO2 was saved through the reuse of steel, how much was saved through the reuse of heaters, and also how much more expensive or how much cheaper were the different components. And then the use, so how to extend the life cycle. This is this diagram, maybe you know, by Stuart Brand. Is this diagram by Design for Disassembly. The idea is always to separate the different systems that have different life cycles. So, for example, the structure, which can have up to 200 years, that it can be separated from the skin, which maybe can have 40 years or something like that. And this is not only important for design for disassembly, also so that it can be maintained, no? So that we can repair different pieces without having to demolish the whole building. And this is an example that we crossed last year, the St. Gallen Provisional Theatre, which was a theater that was built as provisional while the St. Gallen Theater was built. And it was meant to be there for 4 years. And it was a beautiful building, all out of wood, with a metal sheet as facade. And they could not find a further reuse for it. And we tried to, the costs for dismantling were 400,000 francs. And we were trying to then also reuse all the components in all our projects. Of course, our first priority was to reuse it as it was and not to dismantle it at all. But there is a date when they will demolish it, and then if nothing was found for it, then of course. So we were basically trying to find a use for it in somewhere else, and it was a bit, everyone was very worried about it. That was last year, and this is from this year, where there was a city in Ingolstadt in Germany who actually adopted the Provisorium Theater, and it was dismantled a couple of months ago, and it was driven to Germany, so to work as a Provisorium Theater, no? Mm-hmm. So this idea of, is it really, how do you extend the life cycle, no, of these components in the best way? So always, as much as possible, to keep the building as it is. And this is already in the process of reinstalling the theater. And this is another project that we did with David Banner Architects, which is it was a Basel Cantonal Bank, and the facade needed some refurbishment. It was the question, should there be a new facade? And then the idea was to, is it the end of its use, or can we rather refurbish it? And the idea was then to keep as much as possible These were some of the principles: energetic improvement through better insulation, only replace one of the glasses, do all the refurbishment on site so there's no transport, and reuse as much as possible the facade. So basically the idea was to dismantle the facade, put more insulation where needed, add one extra glass, repair the storages also, and create as little impact as possible, do as little as possible. And yeah, the whole facade was dismantled and then reinstalled. And I come to the last chapter. So we go back to end of use, where are the materials coming from? And this is a bit what we do when we find a building that is going to be dismantled. So the first is an analog inventory, where we assess the potential that the components have. When it's small components, especially, it's just analog, so taking the dimensions, seeing the potential that they have. And some components that are more difficult, like a steel structure, is a digital inventory. So this is a scan to beam that was done for the point cloud scan for the Hagenholz for the City of Zurich competition for the ETSAB Recycling Center. And so that we have done also for a few projects. I mean, we have not done them ourselves, but this is also assessing the demountability. So there's components that are very easy to dismantle. For example, with windows, one can see very easily which ones are very easy to dismantle and which ones will be more difficult. With steel, for example, sometimes it's a bit more difficult. I will now show one example. But this is also something that you need specific people, professional workers that are trained into this. And also something that is a bit specific to reuse the tendering for deconstruction. No? So how is this written that it assures the deconstruction, the well-done deconstruction, the professional deconstruction, and not the demolition this is an example, dismantling concept that we did in a mine in Plattenstrasse for the radiators. So exactly where are all the radiators that we want to dismantle? And then the professional dismantling. So how should they be dismantled? For example, these radiators, as soon as they're a bit bent like this, the tubes that are inside, they break. So it's very, very important to, when they're being dismantled, to keep them completely straight so that the tube inside doesn't break. And this was, for example, one of the problems. So it's very important to have people that are workers that are professional, that know how to do this, because it's not the same as normal. And then also the tagging inventory. So for example, by radiators, maybe it's not so specific, but for example, here there were radiators with different dimensions, and it's important that they're stored in a way that they're easily identified afterwards. And yeah, the professional storage, no? Like how should they be? For example, here, in order that there would be no weights on top, exactly for the problem I was mentioning before, they were also they were covered with a frame. And maybe this is a bit more of a complex example. This is the dismantling of the Schneider warehouse, which you saw before in the competition proposal from Graber Pulver Architects for the City of Zurich competition for the recycling center. I was told to work. And this is basically, this is the project that they proposed to dismantle and to reuse, that we could reuse the steel structure in the new recycling, and recycling center. And this is how it was done. So basically, all the facade, everything was taken away, and this is the steel before being dismantled. And this is another mine. So in this case, you can see that the steel came out very, very clean. So there were no problems at all. The facade, as we said before, designed for disassembly, very easy to take away the facade, and the steel came very clean. And this is another example where it was more difficult. This is the Stratego office building, also for the same competition for the ETSAB Recycling Center. And here, for example, it was actually a video, but I think it doesn't, that's why it's a bit blurry. But here, for example, some of the steel beams, they were in between the concrete. So when they were einbetoniert, and when they tried to then dismantle it, it was quite difficult, some of them. So it's also, as I was saying before, the dismantling is also it's quite specific and it needs to be designed, and sometimes there are difficult. And also something that is quite special by reuse is this tagging or inventory. So actually, for example, the recycling center will be done in the competition of the city of Zurich. It will be rebuilt 1-to-1. So it's very important how we will tag these components to make sure that we will know which component, not only which column is which column, but also how were they placed. So for example, this is the Schneider warehouse, which I showed before. And what's interesting is that they were actually already tagged, all the columns. So they were engraved with a tag. And by this, we could already know which columns and which beams we were talking about. The problem is that the nodes were not tagged. So actually we knew that this column was this column, but we didn't know if this was the top or the bottom, or if this was placed like this or placed like that. And this was important for the future. So then what they did, they used these other tags to show the connections. So for example, this is the connection 10.1. So then we know that this column was placed like this and not like that. And this is also quite complex. For example, the Schneider warehouse will need to be sanded. And how this will be done with the metal plates, I mean, it seems like it's not a problem, but for example, now we're thinking, for the next one, we're thinking, we have discussed of a new way that it will be done with plastic tagging until it's taken to the, I mean, it's one of the, we're actually doing this in another project in Basel, for Basel City. And we are doing some tagging that is just glued onto them until they're taken to be sanded. And once they are sanded, then they engrave again the tagging. This is something that is still in progress, and we're also doing in different projects now. But that's a bit the idea, is that after it's sanded, it's much better than to sand it, so that in the future it can also be reused, no? And this is also the plan. So that was also a bit complex, for example, because we had the original static drawings, but we needed to draw also all the information about these different connecting points. And I don't know, it's okay in terms of time, or we got a bit? Yeah, okay. And then also the storage. So how they're stored is also something that is quite specific, no? So how do you do that the water won't get installed? For example, these columns, they had a very special geometry. And then how do you store them, no? That the water doesn't get through, but also they need to be covered to be protected from the rain. But at the same time, they need to be ventilated so that there's not, so it's a bit also very specific. And as it's not something that it's yet under norm, I mean, we need to speak to a lot of people from BAFU to really understand what are the recommendations, as it's not really one way to do it right now. This is also the steel from the other mine that you saw that was a bit more difficult to dismantle. So it also made it to the site. And this is the storage concept. So something that we also do for components to understand how much area they will need to be stored. It's also something that is important, no? So in order to assess, like, I mean, when it's needed, we also redraw them to try to understand how many square meters will be needed. This is important also in terms of the costs, no? Because the less, when you need to pay for the storage costs, so when you cannot bring it directly on site, or when you cannot, maybe with public projects, sometimes it's a bit easier, but when you need to pay, it's also very important how much square meters you will need to store this. Also, if it's inside or outside, for example, it's important, no? Because inside space is much more expensive. And then the logistic concept. So for example, by transporting the components by train, you can reduce the CO2 emissions by a lot more than when you transport them by truck, no? So with the concrete plates, at some point we try to also transport them by train, so that this would also reduce by a lot the CO2 emissions, but of course it's very difficult. But to also keep in mind this logistic concept, no? That you also design the process. And this is also an image from the ETSAB Recycling Center. And the idea here is that we needed between the concrete plates, every 2 concrete plates, we actually needed a wooden beam. And at the beginning, we tried also to have this reused because we thought it was a bit weird to be reusing concrete plates, but then to be getting new wood. But at the end, it's very, very difficult to find. It was very difficult to find reused wood exactly on time for when the concrete plates were coming. And then what we thought is, okay, if we take, local wood and, even if it's new, what we can then do is reuse it in the project as well. So now what we're trying to do, we have 500 linear meters of super beautiful wooden beams, which will maybe not look so beautiful after 2 years under the rain, but still, which can be reused in the project as well. So now we're trying to implement that. And then the material passport is what comes once the components are already dismantled, transported, and stored. We do a material passport so that in the future they can also be reused. This is an example of the City of Zurich refurbishment of Kindergarten Möslistrasse. And these are just some of the Bauteil passports. So in the Bauteil passport, you can find all the information also, for example, if there were any toxic products, if there were, from which year was it dismantled. I don't know if the product has, all the information that you need about this component so that you can reuse it also in the future, or even for maintenance. No, for maintenance, it's also important to have this Bauteil passport. And then also this is the Übergabevereinbarung, so it's a contract. We have also developed a lot this legal framework, and this is a contract so that the component can be given from one owner to the next owner. And this is also something that is important so that the responsibility, the warranty kind of goes from one owner to the other. This is also a topic. And the tendering for the new installation, this I think was one of the questions before. And this is also a bit special. So it's not the same thing, a tendering for the installation of a new product as the tendering for the installation of a reuse component, because of course, depending on which component, if it's a lavabo, it's almost the same, but if it's a steel structure, it can be much more different. And how to design these tenderings is also something that we're now doing in different projects. And then to finish the circle a little bit, this was a bit the question that we discussed. What are the challenges for the next 5 years? What are we seeing? Where are we going, and what are the next steps? One of the biggest challenges with reuse is the uncertainty. So this is something that it's very difficult to really to plan 100% with reuse. So it's not like when you get a new product and then you're designing exactly what you want. Here you need to accept some things that come with the material. And sometimes we run into surprises, no? So for example, this is the same Kerenzerberg tunnel, the ancillary extension. And as I said before, there were 20 kilometers of wooden beams, and we also tried to reuse them in different projects. And after doing many tests, one of the tests, of course, because they had been for 1 year in the underground tunnel, they had a bit of moisture and they had a bit of fungi. And because of this, of course, the wooden engineer said it was okay if we dried them, but it was a bit of a question, can we really, for example, reuse them in public programs inside if they... So this uncertainty is something that, there's many examples of components that after we did some tests, they did not move forward. This is, for example, one of the mock-ups that was done with CAS Architects, where we did a Brettstapeldecke with these beams to test them before we found out that, that they could not be, that they had this pilze. And another challenge is this reuse tenderings. So for the public projects, it's also a bit of a challenge. This is just an example, to show like a bit where are the different threshold values. But when we go over a certain value, everything needs to be open, And how to do this with reuse, it's also one of the challenges. So hopefully, as we were discussing, if the big producers will take back their products, then you will be able to buy steel in Eberhard, for example, new or reuse. And because of that, it will be easy to then make a tendering where you ask for I don't know, AGB, you say exactly which profiles you need, and you say that they want to be reused, and then these companies will apply to the tender. This is the idea of where it will move in the future. Maybe right now it's still a bit difficult, but it's where we think it will move in the future, in the next years. And then the logistic necessities, that is also a challenge, like I've been saying. So in some projects, in some public projects, we do, for example, receive available storage, but in others we don't, we have to pay for it. And this makes everything a lot more difficult, of course. Also the fact that the storage is close by. So, I mean, this is the hunting map of the K118, which you will visit tomorrow, and where all the components come from the building. And if you look at this, I mean, one understands how difficult it is to find then the storage spaces that are also on the way to the construction site. So you also, I mean, this is also part of the CO2 reduction. If you end up finding storage space is not so easy. And if you then find the storage space further away, you know, it also makes everything very complicated. So for example, to give an example, we were looking for a floor finish, Kopstein, so like a stone floor finish for a project. And we found it and it was 1 hour away. And then we calculated the CO2 emissions that would take the transport, and they were actually higher than the CO2 emissions from producing the material new. So this is also something that we always take into account. We always, when we do these search profiles, we always say, what is the maximum distance that the material has to be found at, to make sure that it doesn't overpass with the transport. But that's also a challenge. Then the specialized professionals, like I said, and of course the timing. And then of course the political instruments. So for example, one of the political instruments that is already being put in place is thresholds for embodied energy. So right now we are at, like I said before, the 660 kilogram CO2 equivalent per square meter, which is this 11 when you divide them by 60 years, which is the average. And this is right now where this is the average of construction of new buildings in Zurich. The idea is that by 2050, we are here. So we're in netto null, 10% over netto null. When we look at the case of K118, so this building that you will go visit tomorrow, which is renovation, so it's using an existing building, it's using all reuse and biogenerate, so it's only using a wood, straw, and then reuse materials and very little concrete. So for example, there's concrete you will see tomorrow in the steel beams because of branch shoots, because of fire regulations, but very little new materials. And when we look at that, K118 is at 4.1 kilograms per square meter. And that means that by 2030, all buildings will need to be at the same level as K118. And yeah, that's quite challenging. That's a big challenge. That's a big challenge. How to do that? Yeah. I think it's important to be aware of this because it shows the urgency of the situation. It shows that when we're talking about applied research, it's because there's no time. So the reason why we're testing sometimes solutions is because there's no time to spend 10 years doing the research and then testing it out. And that's why, and I think that's also why there are, mistakes or there's optimizing to be done. But I think the important thing is to move forward. And other political instruments. So as I was saying, also building screenings and disassembly mandatory. So to make this mandatory, this is a pre-demolition audit which Zirkular developed 2 years ago, which makes it in Germany, it makes it obligatory, this disassembly. And there's also the EU taxonomy for sustainable finance, we're also expecting that will also be an important change. And then the legal framework, it's also an important one in terms of process, for example, for the project credits, for the warranty of reuse components. And if you're interested, there's a project that was done between Zirkular, Bauburg in situ, and the ETSAB. And it's online, and there's many different documents that were developed in terms of warranty process and different documents that are very important in terms of the legal framework for reuse. And if you're interested, I left the website there. And just to finish, to say that what we're doing is also not something new. That's a building from 2008 and a building from 551. And basically, we're not sort of innovating, or I mean, we're kind of only fixing, what took place, in the industrial revolution. I mean, since the industrial revolution, and trying to go back with what kind of for us makes sense, and hopefully we can manage it.